I found this lathe on the Facebook marketplace. It's a bench lathe. It's a Yangzhou TY-C0632, same as the Grizzly model G4016, 13.5 by 40 gearhead lathe. This particular lathe is no longer available, at least on this form. The lathe is made in China. It's a pretty good size for a beginner. That's the reason I wanted to have it. I had to go and get the lathe out of town, a drive of about an hour and a half. When we got there, the lathe was in pretty bad shape and the guy pushed on the contactor to show me the motor running. So the motor ran for a couple of seconds and I thought it was okay, so I completed the purchase and head back home. So I started to disassemble the lathe as soon as I got home to be able to unload it easier, and I figured I was going to restore it anyway, so might as well just take it apart. I started by cleaning the bed and the cabinet. I've been using this strong solvent to clean grills and stoves, and it's pretty strong. And one of the first mistakes that I made is to spray the lathe with this strong solvent that erased all the labels and graphics. I didn't want to worry about the labels at this time, so I started to clean, paint, and assemble all the pieces one by one. So after getting all the sections ready, then it came time to do the motor. The fan motor was broken, so I tried to find it on Amazon and Grindr and eBay, everywhere. I just couldn't find it. Also, the starting and running capacitor casings were incomplete or missing, so I had to make those too. Taking some measurements of the fan and the caps for the capacitor enclosures. I used Fusion 360 to design the STL for both of the caps for the capacitors and the fan. Using the 3D printer, it took about 15 hours for the fan to complete. The capacitor caps were completed in about 11 hours. Meanwhile, I was cleaning and painting the motor. The parts got done and then I put the motor together. I hooked up the cables to go to the motor. But another thing that was broken was the reverse and forward switch that gets activated by a lever on the apron of the lathe. It is a special contactor that rotates and turns on one switch or the other. One of the switches was broken, so I glued both of them together with epoxy. So I plugged the lathe in, tried to test the motor, and by my surprise, it didn't run. Well, it did run, but it was drawing a lot of current and it was making a lot of noise. I tested the resistance in both the starting and running windings, half an ohm in both of them. The running winding is supposed to have like 3 ohms and the starting winding is supposed to have like 5 ohms. So probably some of the wires and the winding were like touching each other. Now after all that work with the fan and the capacitor caps, now I had to search for a motor. I couldn't find a motor anywhere. So Harbor Freight Tools came to the rescue and I got the 2 horsepower motor. It's a 2 capacitor, 7/8 of an inch shaft. Since the shaft was smaller, then I had to get me a new pulley. So I went to Grindr and got me one. It was $60. So the Smith Jones motor is great. However, the flange that attaches to the lathe is totally different, so I had to fabricate out of a piece of aluminum a plate. And to do that, I had to drill some extra wide holes. My only choice that I had is just using a Forstner bit for wood, so I had to use it for aluminum. And I was having a hard time to get it to dig into the material. But finally, I realized that if I just eliminated the edges of the Forstner bit, then it cut the material like butter. Now I know how to cut big holes on soft metals like aluminum. So after making some threads on the plate, then I painted and I was able to mount the motor onto the lathe. I got the 2 belts from Ace Hardware and I put it all together. So finally, I thought I was gonna see the lathe running. Now the connections for the motor, to make it go forward and reverse were not the same as the old motor. There's a combination that you have to do to make it go forward or reverse, and it's a little bit complicated to figure out, especially if you're gonna use 2 contactors. In order to do these connections, I had to strip all the wires from the spaghetti on the contactors and start from scratch. I suppose I could use a barrel switch to be able to reverse it, but this lathe has some of the functions that you need actually the contactors. For example, it's got the jog button and also the emergency stop switch. And since the forward and reverse switch is located on the apron of the lathe, you had to run smaller wires with lower voltage all the way to that switch. So it took me a while to figure out the way of connecting those 2 contactors with the new wiring for this motor. Here's an illustration of how I connected the wires. You can take a screenshot if you have a similar situation. It took me some time to figure it out, so perhaps this will save you some headaches. However, the forward and reverse switch located on the apron just worked a couple of times and then it broke, so I had to replace it with the barrel switch that I had from another machine. Another thing that I had to do is install some breakers because this electrical panel had the old style fuses and I didn't have the way to turn the power on and off except for the emergency stop switch. So I figured that I install a couple of breakers. So I designed an enclosure on Fusion 360 and 3D printed and ended up being real good. So finally I got to do the final touches on everything. Now my next thing to do was to solve the problem on the erase labels when I spray them with the strong solvent. So I always wanted to have a printer that would print labels and stickers. And the solution for that was the Epson EcoTag, one of the cheapest ones that I had to convert into sublimation printer. The way to do that is just buying the special ink that goes in the printer. Don't use the original ink that came with it. And the special paper is called sublimation paper. What allows you to do is just transfer whatever you printed into a surface that is made of polyester through a heat press. The first thing you had to do is just create the graphics on a paint program and then just print it into the sublimation paper. Then you heat press it into a polyester based substrate or surface, or you can directly print it into a special vinyl that is made to print stickers. So most of the information plates on this lathe are stamped into an aluminum sheet. So in order to print to an aluminum plate, you first have to cover it with a polyester based film. So you can use lamination pouches for that. So first you had to press the pouch into the aluminum. Then you press the sublimation print into the aluminum plate. There's a lot of videos out there that describes the sublimation printing process. So I got pretty good results to be the first time I did this process, as you can see on the labels here. Here's a small demonstration video that I made after I finished everything, so I could just post it into the marketplace. I had more clicks on that video than my regular videos that I upload to YouTube, so I think it looks real good. Very well, so this finishes the story with this Yangzhou lathe and all the stuff that I had to do to make it presentable and put it out there so somebody will enjoy it. Alright, thank you very much for watching and I will see you in the next video. Bye bye.